on Flipping Science, we're going to be looking at electron configuration Year 12 style. So what that means is it's a little bit more complicated than what you did in Year 11. The way it works is, rather than just doing 2.1.3 or whatever it was, that probably wouldn't exist, 2.8.3, we look at exactly where the electrons are in terms of main shells, subshells, and orbitals. Okay? So rather than thinking of just one electron shell as being just a solid shell with electrons around it, those shells are broken up into smaller parts. So when we represent it, I'll use a diagram like this to help me. Each of these things up here means something. So the number at the front, the big number at the front, that represents the main shell. So last year you would have done 2.8.1, so that means you had 3 main shells. So 1, 2, 3 main shells. So 2 for the first shell, 8 for the second shell, 1 for the third shell. So we represent that as a big number at the front. Then we use some letters, so S, P, D, and F. Those letters mean, those letters are the label we give to the subshells. So we have different subshells, and each subshell can have a different number of electrons in it. So an S subshell can have 2 electrons. A P subshell, it has 3 what we call orbitals, and they can have 2 electrons in them. And D subshells have 5. F have more, but you won't really worry about F because you don't get down there. The first number is the main shell, the letter next to it is the subshell, and then we use a subscript number to show where the electrons are. It makes sense when you do it. It's a bit easier to do it. The way we fill the subshells, we don't just go 1, 2, 3, 4, because some of the subshells overlap with each other, and again it gets complicated. So the way we fill it up, we use this diagram here. We go 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. That's about as far as we'll get. Now, just saying it like that, you need to remember it. There's a nice little song, and I'll put a link to the YouTube video on this one, so you can get the song. That goes up to about here. You just need to remember the next ones. Alright, so we'll do some examples. The best way to learn how to do this is by doing examples. We'll start by doing hydrogen. Okay, so we find our periodic table, we look for hydrogen, it's in group 1. So, group 1, that means it has 1 electron in its outer shell, it's got 1, the atomic number is 1, so it's got 1 proton, so it's going to have 1 electron in the neutral atom. So, do hydrogen to start with, it's got 1 electron. The way we represent it is with, each electron is represented with a half arrow. And we do 1 half arrow going up, 1 half arrow going down. That's because each orbital contains 2 electrons, one spinning in one direction, the other spinning in the other direction. So, for hydrogen, when we fill this in, we do 1s1, we do a half arrow like that. Okay, so how we represent it, 1s1. What that means is, the electrons for hydrogen, they're only found in the first main shell. The type of subshell it's in is an S subshell, and there's only 1 electron in it. If we were to do helium, which is the next one along, number 2, so I'll save paper, so we go helium there. It's 2, so we need to put a second electron in, so now the shell looks like that. So the way we represent that is, rather than having 1s1, it's 1s2. So there's 2 electrons in an S subshell in the first main shell. We'll make it more complicated now. So from there, let's do an example that's a bit more complicated. Let's do something like sodium. So sodium is number 11. Because it's number 11, that means we've got 11 electrons that we need to put in. And we go from start all the way through. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice how I fill it in. I go halfway first and then back down the other way. There's a reason for that, and we'll talk about that a bit later on. So now if I look where my electrons are, I've got 2 electrons in the 1s subshell. I've got 2 electrons in the 2s subshell. I've got 6 electrons in the 2p subshell, so 2p6, and I've got 1 electron in the 3s subshell, so 3s1. So 1s2, 2s2, 2p6, 3s1. So, where are my electrons? That's all this is saying. I've got 2 electrons in the 1s subshell, 2 electrons in the 2s subshell, 6 electrons in the 2p subshell, and 1 electron in the 3s subshell. Right? How does this relate to the periodic table? If you count up the number of electrons in each of the main shells, so in the first main shell I've got 2, the next one I've got 8, and in the third one I've got 1. If I add those numbers up, 2, 4, 6 and 1, I should get 11, which is the number of electrons that we need to transfer. And it's also the electron configuration, the number of electrons that surrounds the nucleus. Right. So that's sodium, so that's an example with sodium. Let's do a little bit more complicated. Let's have a look at chlorine. So we'll find chlorine, it's down here, number 17. So chlorine, 17 electrons, so we need to fill them in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So if I write it out, 1s2, 2s2, 2p6, 3s2, 3p5. So all I've done, I've written the number of electrons in each of the subshells like that. This tells us something about chlorine. It's got one electron missing down here. So to make chlorine stable, it would be good if it had another electron in there. And that's how it makes the ion. And we'll go through that a little bit later on. We'll do copper now because it's interesting. Now, there's a rule. Full subshells are stable. Half-full subshells are less stable, but still really stable. Shells that are kind of not half or not full aren't particularly stable. So this is where we'll have a look at copper. So we find copper on our periodic table, number 29. So you put in 29 electrons. So write 29 next to it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20. 1, 22, 23, 24, 25, 26, 27, 28, 29. Now, if I fill it like that, there's a bit of an issue. I have a full 4s subshell, but I've only got 9 electrons in my 3D subshell. So even though I've drawn it like that, that's not correct. So bump on. Instead, what we do with copper, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So now when I write it out, it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. So the reason why this is important is we now have a full 3D subshell and a half full 4s subshell. So what that means is this one is stable because it's half full, and this one is stable because it's full. There's two that you need to remember. One is copper. Alright, so on our periodic table, one is copper, the other one is 5 before, which is chromium. Okay? Chromium does the same kind of thing. It has a half-filled 4s subshell. So they're the two that you need to remember. Otherwise, basically, you just fill up from the start. That's it for Flipping Science today. So that's how we find the electron configuration of an element up to number 38, year 12 style. See ya.